In this lesson, you will learn how to calculate the axis of symmetry and vertex for quadratic functions. Remember that some of the parabola key features are a vertex, which is the point at which the function goes from increasing to decreasing, or vice versa. So in our graph here, our vertex point is here where it changes from increasing to decreasing, or the other way, decreasing to increasing. The maximum or minimum point of the function is our vertex. That's the highest or lowest point of the graph. Also remember that the axis of symmetry is the line that passes through the vertex, and it's the line of reflection or line of symmetry. So this line is our axis of symmetry line. It always will pass through the vertex point, and it also cuts our parabola symmetrical in half. But how can we find an axis of symmetry and vertex without a graph? So in order to find the vertex when not given a graph, this will only work for equations in standard form. So the y equals ax squared plus bx plus c. The axis of symmetry can be calculated with the formula negative b over 2a. And that value will be the x value of the vertex point. Since that axis of symmetry goes through the vertex, once you find that value of the axis of symmetry, it will be the x value of the vertex point. So that means we will substitute that x value into the quadratic equation. So we'll just set it up so we can plug in the x, and we will evaluate for the y value. Once we have that, we will be able to write the x value that you found in step 1 and the y value. There should be an e. So we will find the y value from step 2 as an ordered pair and represent that as our function. We can also talk about whether the function has a max or min, and that's going to be based off your a value. Again, going all the way back to our standard form, that a value in front of the x squared term will tell you if you have a max or min. So if the a is positive, meaning it's greater than 0, the graph is going to open up. So remember our smiley face image to help you know that this point is the lowest on the graph, so it will be a minimum. If a is negative, meaning that a is less than 0, then the graph is going to open down our frowny face. Then that means our vertex is a maximum. It is the highest point on the graph. So let's go ahead and look at some examples. So example number 1, we have y equals negative x squared minus 4x minus 5. We're going to find the axis of symmetry and vertex for this quadratic function, and then determine if the function will have a maximum or minimum value. So we first want to start with naming our a, b, and c. Because this is in standard form, we can name each of our values for a, b, and c. So a equals negative 1. Remember, it's the number in front of the x squared term. B equals negative 4, the number in front of the x term. And then c is the constant at the end. To evaluate to find the axis of symmetry, axis of symmetry, I abbreviate A of S. So axis of symmetry, we will use our formula. X equals negative B over 2A. And I do set it up with negative 1 times B, just so you can correctly calculate in this formula, especially when your B is already negative. So let's do that now. So negative 1 times negative 4 over 2 times our A, which is negative 1. So you can use the dot for the parentheses, or even better, sometimes just using the dot for multiplication or use parentheses. So negative times negative is a positive 4 over positive times negative is a negative 2, and then we will divide to simplify that answer. So our axis of symmetry is x equals negative 2. Now to find our vertex. Well, we already know if it's an x, y ordered pair, this is our x, y ordered pair, we already know the x value. That will be negative 2. You will just put that in the x spot of the coordinate for the vertex. We now need to set up using our original equation to try and find y. So we have y equals, I'm just copying my original equation. So y equals negative x squared minus 4x minus 5. We're going to plug in that x. So negative, remember this was a negative 1 as our a. Then we're going to square the negative 2 minus 4 times negative 2 minus 5. And this is definitely where it's going to be important that you substitute using parentheses, because squaring a negative 2, you must have parentheses around it or else it will not work correctly. And then really at this point, I recommend using your calculator. It knows order of operations and will work this out correctly. So once you set it up, type it all in the calculator. Of course, type it in correctly and let it work out the order of operations for you. So negative 1 times negative 2 squared minus 4 times negative 2 minus 5. Setting all that up, making sure everything is written correctly, and that gives us a value equal to negative 1. So that gives us the y value of our vertex. Let's just write it here. The negative 2 was our axis of symmetry, and the y value is negative 1 to finish off our vertex. So the last part is to determine if the function will have a maximum or minimum. Remember, we will look all the way back to our a value. For max or min, look at your a value. Because our a equals a negative 1, remember that's the sad face, a is a negative. Because this will be the highest point on our graph, this vertex will be a maximum. If a is a negative, we will always have a maximum for our vertex. Let's look at another example, number 2. Here we're going to have y equals x squared plus 4x. Well, we're still going to start the same with naming our a, b, and c, but notice in standard form we actually don't have a c. So if you want to, you could add a 0, because that's what your c value is equal. Our ax squared term we have, our bx term we have, it's the c that's missing, but we could tack on a 0 if that helps you. So let's name our a, b, and c. A equals not x or even x squared. Remember, it's the number in front, so that would be 1. B equals 4, and c equals 0. We'll plug those into the axis of symmetry formula. So that's that negative b over 2a. So negative 1 times the 4 over 2 times 1, and then we'll work that out. Multiply the top, we get negative 4. Multiply the bottom, we get 2. And when we divide that answer, we find that negative 4 divided by 2 gives us a negative 2. That is our axis of symmetry value, which is going to end up being the x value of our vertex. So that is going to go in, and we need to find the y value. For the y value, we're going to substitute this axis of symmetry back into the original equation. So let's just recopy the equation first. We don't really need the plus 0. That way we can plug in the -2. So plugging in -2 everywhere you see an x so that we can work it out and solve for y. So again, once you set that up, you can solve this with order of operations, but because the calculator knows order of operations, let's go ahead and let that help us solve that for our variable y equals -4. So for our vertex, we get an ordered pair -2, comma, -4. One way you can check this, of course you could look back over your work, but the graphing calculator can really be helpful for this as well. So let's go ahead and actually hit that y equals button. On the top row, there's a y equals button. Type in the original equation, so x squared plus 4x. If you go second table, you can scroll up and down until you find what you think is the vertex. So let's go to where it is. Here we think that -2, -4 is our vertex, and look, it is matching out. Another thing to notice, with the vertex in the center of our parabola, remember that's where it changes from increasing to decreasing, it's got that change of the U shape. Look at the y values on either side of what we're calling the vertex. That repetition is going to make that U shape. So this is a great way to check your work. One, you should see this ordered pair as our vertex, and you should see that repetition on either side to know that that truly is the vertex point. Because let's say, for example, you did all your work and you got, instead of a -2, maybe you got a +2. Well, you would have done the work and still gotten the 12, and yes, that would have checked out. However, we don't see the repetition on either side to really make that U shape. So that's how you could check to make sure you have our vertex in the right ordered pair. You could even hit the graph button and actually view the graph, but that's a little bit harder to see that vertex point. Let's go ahead and determine if this point will be a maximum or minimum. So looking at our A value is 1. So that means it's our smiley face. That A is positive. Because our A is positive, our vertex will be the lowest point on the graph, so it's going to be a minimum. Every time that our A is positive from the get-go, we had an A that was positive. Every time that our A is positive, that is going to make us have a minimum vertex point. Let's look now at example number 3. This time we have the equation y equals -3x squared plus 7. Feel free to pause the video now and try this one on your own. Notice in this one we have y equals ax squared plus bx plus c. We have an ax squared term, but it's the bx term that we're missing. So when you name your a, b, and c, a will be -3, b is equal to 0, and c is equal to 7. So let's set this up in our axis of symmetry formula. So x equals -b over 2a. So we have -1 times 0 over 2 times -3. -1 times 0 is 0. 2 times -3 is -6. And when you divide, that's going to equal 0. So here's a little tip. When b equals 0, your axis of symmetry should always equal 0. Because the 0 is going to be in the top, and when you're dividing into 0, that always equals 0. So for our vertex, we know that that is our x value, and we need to solve for the y value. So let's substitute the 0 into our equation. So y equals -3 times 0 squared plus 7. Again, we could use our graphing calculator to help us work that out. Or this one's fairly simple. Exponents, then multiply, and finally add. So we should get 7. Let's check that. So -3 times 0 and square that. Finally add 7. It does. Gives us 7. So for our vertex point, we get the ordered pair 0, 7. Let's check that, or let's go ahead and name our max or min looking at our A value. A is a negative. That's our frowny face. A is a negative. So that's going to give us the vertex being the highest point on the graph, which gives us a maximum. Let's walk through those steps again for the graphing calculator. You hit y equals, of course clear out anything you have in there, and you'll type in your equation. -3x squared plus 7. You'll do second table and view that table. We want to scroll to what we think is the vertex. 0, 7. And it looks pretty good because we see that repetition on either side that's going to form that U shape. And again, we could graph or hit the graph button to see the actual graph. And that also helps us check if we're getting the max or min correctly. We can actually see that maximum value for the vertex. So let's write down those steps for the calculator. So you'll hit y equals, type the equation. If you need to make the note when you're typing your equation and y equals, the mode key underneath that is where you can find x. There is other ways you could do it with the alpha key, but if you are typing in and you need an x, here underneath the mode key is your x variable. Once you type in your equation, you'll hit second table, tables on the graph button. When you go to second table, you're going to look for the vertex. And you should see that repetition in the table on either side of the vertex because that makes that U shape.